Welcome back. I'm Richard D. Hall and I'm talking to Andrew Johnson about alleged free energy devices. Now you might be wondering what this is on my desk. I've done my own little bit of research to try and look into the claims of somebody called Stan Myers. Now Stan Myers allegedly created an energy device which was quite simple in its operation seemingly, and he was supposedly driving around America in a car powered by water. This was in the mid-1990s, and he was approached by the military, who wanted well, I think he went to the Pentagon eventually, yes. And they wanted to secretize his technology. That's what they told him. When he refused, not long after that point in time, he came running out of a restaurant saying he'd been poisoned and he dropped down dead.
Right.
Okay. Let's just take a little look at this clip from Stan Myers in 1995.
My life has been threatened many times. Of course, I happen to believe in the power of angels. And if I don't believe in the power of angels, I don't believe I'll be around here too long.
For 20 years, he has been refining a method to fracture water, which produces vast amounts of hydrogen on demand. Alloy rods, acting as electrodes, are housed in a perspex container that's filled with water. Normal mains voltage is fed in through a transformer, but critically, there is virtually no current consumed, less than ½ an amp. The result is dramatic. Hydrogen pours off with the flick of a switch. Meyer claims the key is his electronics, which pulses electricity rapidly across the rods at up to 20,000 cycles per second. Whereas in conventional electrolysis, 3 times as much energy is consumed as is produced in the form of hydrogen fuel. In Meyer's apparatus, the reverse is true. It appears to produce several hundred% more energy than it consumes.
We brought the water fuel cell to Washington, D.C., and of course I had tweaked it in such a way to produce an enormous amount of hydrogen, oxygen, gas, and the patent examiner said, no, it will not work. Based on the electrolysis process, and when we turned it on and produced an enormous amount of hydrogen and gas, the examiner finally realized that we were doing exactly that, and went out in the hallway and started screaming and hollering to everybody on the floor, put out all your cigarettes, hydrogen's in the building. So we started laughing and said, well, we certainly convinced everybody in the patent office that we can do what we said we can do.
He is currently modifying a beach buggy to run on nothing but water.
Well, I first got involved with Stan Meyer when I went over there with a couple of colleagues to look at his water-splitting device. And so we arrived at Stanley Mayer. He had a demonstration cell. We filled it with tap water. In fact, I did that myself. And he switched it on, and almost instantly there were 3 jaws dropped because of the rate at which the gas poured off. It was quite spectacular.
Whatever energy source Stan Meyer had tapped, it was not explicable by the electric power that was going into it. So something was powering it outside of conventional wisdom.
There is no question that the gas coming off in such abundance is hydrogen. Meyer ignites it to produce a high-temperature flame able to cut through metal.
Now then, Andrew, as I mentioned, I've done my own research into Stan Myers, and basically I looked up on the internet everything that I could get hold of, copies of his patents, videos that he explains how this thing works, and really I didn't know what to believe with it. I didn't believe or disbelieve. I was open-minded. I would go onto physics forums where they're just basically laughing at it, saying you can't get more out than in, and I've gone to other forums where they say no, it's definitely. So I didn't know what to make of it. So really, my opinion is you're never going to find out unless you build one.
Right.
Okay, so that was what I tried to do a couple of years ago with the help of a very nice chap called Dave Worsdale. Now, Dave and I collaborated over several months, and we basically built a mock-up of a very basic version of what Myers had. And Dave manufactured these stainless steel tubes. You've got one tube inside another tube, and these come apart. And now I did actually document quite a lot of what I did when I've built the Myers cell with the help of Dave Worsdale, and let's just take a look at it. Now, I mentioned that the pulses that are going to modulate or switch on and off the power MOSFET are being generated by the computer here. Now, this is done by making use of the PC's parallel port. Old computers have a parallel port and they have 8 digital outputs on them. So you can use that port to switch things on and off. You could switch things on and off in your house if you wanted to, using your computer's parallel port. And I've got one of those outputs wired just here, coming into the oscilloscope. Now, the first thing I tried was I wrote a Windows program using C++ in a Windows environment, and I wrote a program to turn that port on and off at a very high rate. But what I found was that the actual pulse width was varying all of the time, because Windows being a multitasking operating system, it's continuously running lots and lots of other programs in the background. So if you're trying to tie up all of the time in one program, it doesn't work, because you can't guarantee that your program is going to run. The time gets stolen away. So I could have tried to use interrupts, but that would have introduced a whole new level of complexity. So what I did was I've installed good old DOS. Using this program, I was able to get extremely precise output pulses from the computer's parallel port, and I'm going to demonstrate this. Now, I needed a programming environment in order to write a program to be able to produce these pulses, and I've written that in Turbo C, which I used many years ago, about 16 or 17 years ago. I used to program in this language, and it came back fairly quickly. So I'm just going to fire up the programming environment on my DOS PC. Okay, so this is it. So this is my program, which actually generates the pulses, and I won't go into the actual program itself. This line here turns the output on, this one turns it off, and the whole program is essentially just variations of turning the thing on or off at different speeds and different rates. So I'm going to run the program. Now, what you see here is a control screen where I can generate pulses, and I can modify the speed or frequency, and modify all kinds of other aspects. I'll switch the pulses on, and we should see the pulses on the oscilloscope. So key number 1 turns the pulse train on, and we can see here on the oscilloscope I've actually got six pulses running at 10 kilohertz, followed by a space of 500 microseconds. So this is known as a duty cycle, and this is what the Stan Myers equipment supposedly ran on. He would have 5 or 6 pulses, or maybe more, between maybe 4 and 12 pulses, on off, on off, on off, on off, followed by an off period, and then followed by the same set of pulses. And the overall time is known as the duty cycle. All right, but we can also modify the pulse width. Now, I've written this control screen here in order to modify all of the different aspects of the pulses. So, for example, I can actually add in another pulse in there. So I can change the number of pulses. So if I just hit Q, there we go, I've got an extra pulse in there, and then another one, and another one. Okay, so I'm adding pulses into that signal. I can reduce them, go down to 4, now down to 3. All right, so now I can also modify the speed of the pulses, or the frequency, by increasing the width. Now I do this by pressing P, and then you can see there, they're just getting slightly longer. So that's slightly higher than 10 kilohertz. Sorry, lower than 10 kilohertz there. All right. Now the other thing that I can do is I can modify what's called the Mach space ratio. So in other words, I can make the on time longer than the off time. And this, I think, is quite important for this device. I can also modify the duty cycle. So I can modify the time that the pulses are off for. We can do this by pressing the U and H key. So I've got pairs of keys on the keyboard. You can see there the gap between the 3 pulses is just coming down. There we go. Or we can increase that. So I've got ultimate control over these pulse trains, and we can go up to about 80 kilohertz, which should be easily high enough for the Myers device. What you're looking at there on the scope is the input pulses to the transistor. So we're not actually connected to the circuit yet. So I'm going to connect it up, and then I'll put the oscilloscope across the simulated cell and see what we get. Right, I've now connected the output of the computer through these two wires here into the circuit, which is switching this MOSFET on and off. I haven't started it yet. That then switches 12 volts through the transformer, out of the other end of the transformer, through the power diode, through the simulated water cell, which is this big capacitor. Now, across this simulated water cell, I've put two resistors in a ratio of 100 to 1. That steps the voltage down so that I can monitor it on the oscilloscope. So the actual voltage measured is 100 times higher than what appears on the oscilloscope. I've also removed the earth from the oscilloscope so I can measure a differential signal as opposed to, otherwise the oscilloscope would affect the circuit. So I'm going to turn on the pulses. Okay, so immediately we see here, this is the voltage across the capacitor, and we can see we've got the pulses here which actually gradually rise each time, and it's 20 volts per division, so we've got 20, 40, 60, we've got about 80 volts there across the cell. Now if I change the Mach-space ratio by increasing the on time by pressing K, you can see, if I press O, you can see the voltage there is going up. So we're now at 20, 40, 60, 80, well over 100 volts, nearly 200 volts there across the cell. So I'll come down. Now what we can now do is, so the next stage of the project is, instead of using this big capacitor, we use the actual hydrogen cell to see if we can generate hydrogen with this pulse train. And tomorrow I'm going to go down and meet for the first time a guy called Dave Worsdale, who has actually built this water cell with the two stainless steel tubes in it, and we're going to connect the two together. We are in the Wolverhampton region, and we're just waiting to meet Dave Worsdale, who we're going to meet at 6:30 p.m, and he's going to take us to a workshop where he has got his hydrogen cell secret location, secret base, Wolverhampton. Over to you, Dave. What have we got inside the coffee jar?
Right, well, this is a Tesco coffee jar, and inside there are two cells, I suppose you could call them, built of stainless steel. The outer is 1 inch OD.
So that means outside
diameter, yeah. The inner is 3/4 outside diameter.
So if you just turn the ends to the camera, Dave, and then we'll get a shot of that. All right, so you can see there we've got two tubes, one inside the other. And how thick are the tubes, Dave?
The outer is 1.6 millimeters, which is 16 gauge.
Mm-hmm.
The inner is 18 gauge, which is 1.2 millimeters. And I think the gap, the resulting gap, is about 1.5 millimeters.
So there's a 1.5 millimeter gap going all the way around.
Yeah.
What type of steel did you say?
303 stainless.
Okay, 303 stainless.
Just standard tube, you know.
All right.
Yeah.
So how have you managed to get them to sit exactly 1.5 millimeters apart?
Right, well, inside I've made some little plastic pips,
Mm-hmm.
which space the tubes,
Mm-hmm.
and also insulate the tubes from one another. Well, at the top of each tube there's an M6 stud,
Mm-hmm.
stainless again. Yeah, the studs are just welded to the tops of the tubes.
Mm-hmm.
This one's welded to the outside of the outer tube.
Mm-hmm.
This one's welded to the inside of the
Right.
inner.
All right.
And they form the contacts.
Right. So you've drilled some holes in the lid of the coffee jar.
Can you see those?
4 holes, well, 5 holes. Yeah.
Yeah.
Okay.
And they're just held in with a nut on either side.
There's an additional hole in there, which is obviously to let the gas out.
Yeah. This is what this tube's for here.
Right.
That pushes into there.
The idea is that when the gas is released, it comes through that tube. The electrical contacts are wired onto those nuts and bolts that you've got on the top there.
Yeah.
And then obviously that would normally be full of water. What were your thoughts on how to seal it, Dave?
Silicon.
Okay. So is this the standard sort of silicon you use in to seal your bath?
Bath sealant, yeah.
A bath sealant.
It can be refilled through there.
Right.
Probably with a smaller tube, because if you tried to fill it through there, you'd get an airlock.
Right.
Yes, the tube is dunked into the bucket, filled with water,
Turned upside down.
turned upside down while still in the bucket, so that yeah, it's filled with water, yeah.
And then you put the tube in.
The gas bubbles up into the measuring cylinder, and it reads directly the volume collected.
You've actually done a calculation as to how much energy equates to what volume that we have.
Yeah.
Yeah. It's always shown as, so this one needs to be on the outlet.
So that's your red.
Like, you want the increase the frequency, yeah? So decrease the pulse width. So 11 kilohertz, 12.5 kilohertz, 14 kilohertz.
If anybody tries this, they've got to understand that it does create an explosive mixture of gases.
Okay, now I did manage to produce hydrogen with the cell, Andrew, and but certainly wasn't at an over unity. There wasn't more power out than in. So I'm still on the fence with the Myers device. But I think when you look at Myers' actual patent, it's not cryptic, but he doesn't write. He hasn't written it in a way that I would say is in conventional engineering terms. It's quite. It's not easy to understand. Some of it's a little bit ambiguous. So, and there are different versions of the circuit. You know, he talks about resonance, but the circuit that he puts forward in his patent, there's no way it can resonate because it's got a diode in it that prevents any resonance. It's more of a pumping circuit, which pumps the voltage up to a certain level, and at that point, it's supposed to crack the water into hydrogen and oxygen, and then you get this supposed flow of hydrogen oxygen coming off, which will come out of this tube, and then you can use that to power whatever. But as I say, the jury's out for me with Stan Myers. But you asked the question, well, why did he get poisoned, and why did the military try and buy his patent?
Well, I mean, I think, you know, we discussed this a little bit before in previous times that we've brought this topic up in our conversations, and I believe that you know one of the ideas that you'd come up with is that missing from the patent was a part of the circuit which was some type of feedback mechanism, which we don't know what that was, and that would then perhaps allow the circuit to resonate. And you know, maybe that's obviously speculation because we can't see that in the actual patent. But what that brings us on to is this concept of resonance, which comes up again and again. That you know, what you can do is, and this is something that Wilbert Smith, you know, talked about in some of his experiments, where you're using some type of high frequency oscillation, whether that's in terms of physical rotation of a disc. You know, going back to Bruce De Palma, he did another experiment whereby he was simply firing a ball up into the air and then watching the path and measuring how long it took to come down. And then he was changing that experiment, and the only way he was changing it was by spinning the ball at very, very high revs before he ejected it up into the air, like, you know, 10,000, 20,000 revolutions a minute this ball was travelling. And in theory it shouldn't have made any appreciable difference to the path that the ball was travelling in this parabolic path, but it did. And the same with this Meyer thing, when you're flipping the electricity in the electrolysis process, you know, 15, 20,000 hertz, because that's what he was using. He was using an oscillating frequency, wasn't he, to crack the water, and that was supposedly the key thing. That's the theme that comes up and again when you're doing things at high speed, you know, sort of figures of 20,000 hertz, 20,000 RPM. Those are when the effects seem to come out, and I've heard Nick Cook talk about this as well in the past. So that's one of the key things which seems to be repeated here.
Okay, Andrew, well, we're going to go for another break, and we will be discussing more alleged free energy devices after this.